Yeah, we are there. Welcome all. Today we'll speak about Terraform. As you know, first of all, it's will be we speak about Spacelift by Marcin Wyszynski. He's a software engineer. Sorry if I named you not right. He's not only a software engineer, he's also chief product officer at Spacelift, and also he's cool guy, very cool guy. And before he start, I have just a little announce that first of all, we will have another meetups on the autumn of this year, also about Terraform. So if you would like this meetup, you can check our meetup.com page, subscribe, YouTube, and so on. And also, Hashicorp user group Kyiv locate in Ukraine. So when you help Ukraine, you also support Hashicorp user group Kyiv exists. So please help. This QR code going to come back alive in UA donation organizations. That's is really good. They help so much our armed forces and help our make this meetup too. So, Marcin. You're on good.
Hello, everyone, and thanks for inviting. Am I still muted?
No. Oh, okay. Oh, yeah.
Okay, perfect. Thanks for inviting me. As one lie in what you said, I'm not cool. I have no sense of humor whatsoever. So, like, that wasn't true. Anyway,
okay.
Thanks for having me. And I'll give you a brief presentation of Spacelift and what I've been working on and basically my thinking behind Spacelift. Let me share my screen. I will be doing the presentation. I'll be doing some live videos or some live show, which, you know, Murphy's Law, it'll probably go horribly wrong. Like anything you try to do live doesn't go well, but give it a go anyway. So hello, Spacelift is the name. I want to give you a little bit of a background, what I've built and why, and show you some really interesting concepts behind Spacelift, something that you'll see as a departure from how tools like this are originally created. So first of all, I'll give you a little bit of story, show you a couple of more concepts about Spacelift. I'll do a little deep dive into the whole layer of policy as code, which is slightly different than what you might be used to already. And then I'll give the stage back to you with regards to questions. So without further ado, let me give you a little story of Spacelift from my perspective, at least. My name is Marcin Wyszynski, and I've been wearing many hats throughout my career. It's been about 15 years since I started my professional career as a software developer, mostly focused on making things run. So I started my career at Google as a sales engineer, building internal tools. I tried SRE. I was a production engineer with Facebook for a while, and then I was a DevOps consultant and release engineer for the last couple of years before I started working on Spacelift, generally as a contract consultant. And I must say that I've built an equivalent of Terraform once. It was in a company called Facebook, you might know it, and it was absolutely awful. Like, when I look at it now and I compare it to Terraform, it's like, oh my God, I didn't know what I was doing. To give you a little bit of a feeling how bad it was written in Python. And if we wanted to roll back a particular operation, we would save the function that rolled back an operation as bytecode in a database, so that when we wanted to run it, we would retrieve the bytecode from the database and we would run it. So every function that was a creation or update would return a function that would roll out. It's like a closure that would roll back the change. And like on the surface of it, it was clever. But when you think about it from a practical point of view, it's like pure madness. Like, why would you ever do something like that? So when I looked, like when I first met Terraform, after I left Facebook, I was like, it was like love at first sight. Yes, that's exactly how you should be doing it, right? With the state, with like, you know, with the execution being tracked, with the dependency management. It's like the DAG that you have created between resources and the plans and the applies is absolutely fantastic. But one thing I was lacking in Terraform when I was working with other people was the sort of multiplayer mode. So, you know, it's similar to Git. When you think about Git, yes, it was designed as a distributed system. And so technically everyone could have the full tree on their computer, and you could be working by sending diffs via emails. And originally that's how it was done. But when you think about the practicality of it, like, no, it's just like not really how you want to work. So multiplayer mode for Git is actually called GitHub, right? That's how they basically made their name. It's a multiplayer mode for Git with a lot of value added on top of it, or GitLab if you want, or Git, or Azure DevOps repos, etc. But like a central server that gives you centralized multiplayer mode, so to speak. So as a consultant, I got to work with the tool that try to address that lack of multiplayer mode. Obviously, as a consultant, you want to be as cheap as possible because you're already charging your day rate, so you try open source. So I used Atlantis for some of my clients. On behalf of some other clients, we bought Terraform Enterprise, or it was Terraform Cloud, Terraform Enterprise from Hashicorp. And for some other cases, I built something, or I built that as part of a larger team on top of a general purpose CI system. So for example, Circle CI. And each of those tools has something going for it. But each also felt to me like it has its limitations that I didn't want to have in my flow. So what I wanted is to ideally have the best of each in one package. And so what's good about each of those tools was that in Circle CI or in GitHub Actions or in Jenkins or in TeamCity, whichever you fancy, they're all similar in a sense. They're great because they're not opinionated and they're infinitely customizable. So like if you want to pre-generate your Terraform code, like run CDK or something like that, like it's super easy to do it. You want to get some credentials to talk to some service, it's very easy to do it. The downside obviously is that you have to do it yourself. Although with GitHub Actions and Circle CI orbs, they kind of did something really clever when they like encapsulated certain steps into reusable chunks. So very well played there. That said, you still need to do a lot of that manual handling yourself. And for Terraform, it was like, the stakes are very high. Atlantis is cool as well. It's a self-hosted, specialized tool. It understands Terraform natively. It's generally robust. People like it. It enforces a certain flow. It generally gives you that ability to comment on PRs and get the feedback on PRs. But in many cases, it's limited, and you can't really scale it in some sense. And also, the flow that Atlantis proposes or enforces is okay for some companies and some projects, less so for others. So it's a great tool, but its limitations are sometimes very visible. And obviously TFC and TFE, it's an extremely specialized tool. It's well thought out. But when I was introducing that to a lot of my clients, what I felt is that there was a lot of prior work to be done in order to squeeze what they did before into the new mode of thinking, because it just runs Terraform, right? It just runs that one thing. And frequently when people build automation on top of their releases, what they want is to do a lot of different things before even Terraform is executed. So in order to do that, you'd have to kind of bend over backwards and try to fit a square peg in a round hole sometimes. So my aim with Spacelift was to build like a combination of the above. So, you know, not be opinionated, be customizable, be self-hosted, and be specialized. Ideally, also, I wanted to go beyond Terraform, because in any significant company or in any company that has significant infrastructure footprint, Terraform is just a piece of a puzzle. And you realize that as a consultant, you get to work with Terraform, obviously, that's my favorite probably, but also you get to work with Pulumi in your companies. You get to work with CloudFormation in AWS shops, frequently in combination with Terraform. You get to play with Kubernetes very frequently in all sorts of ways. And in some older companies with a lot of legacy, you might be playing with Ansible because they haven't bought that immutable infrastructure just yet, or it doesn't pay for them to move everything to like Packer and AMIs and what have you. So Ansible is still running strong there. And so that was essentially what I was aiming at with Spacelift. Basically take the best of each of those tools that I've been using in the past and put them in one package in a way that is easy to adopt, very powerful in terms of automation, very easy to customize, while still being a highly specialized. So let me briefly walk you through the main concepts of Spacelift, just to give you a taste of what it does. So I'll be talking about stacks, runs, Terraform modules, self-hosted workers, or the whole execution model, and then I'll focus in particular on policies, which is very special about Spacelift in general. I'll switch to a different screen to be able to show you Spacelift UI. Are you able to see the Spacelift UI now?
Yeah.
Yeah. Okay, so we can start with the concept of a stack. The stack is very similar to a Terraform workspace. It basically maps source code to a single, like if you're talking about Terraform, it maps it to a single Terraform state file. So if you take one of the Terraform stacks, you can see that, well, it is connected to some repository in GitHub. That's actually the repository here. It's actually connected to a particular subset of that repository. It's tracking a particular branch. So anything that you push to this branch will become like a deployment candidate. Anything that you push to a different branch by default becomes like a test candidate. So you'll get feedback on PR from that. We also support things like storing your state on our backend, but these are minutiae, things that are probably not worth talking about all this much. What is really cool about Spacelift is that it tries to be both specialized and extensible. So we run everything in Docker, like you can bring your own Docker image. So if you want to generate, like, I don't know, use PHP to generate Terraform, which I've seen people doing, crazy, but it's true. You can bring your own runner image. You can use PHP, you can use Python, you can use CDK. You can also use frameworks for CloudFormation like serverless or SAM, and this will just work. Because the second bit of that is the ability to customize the workflow. So if you've been working with Terraform even a day, you realize that there are certain commands that you need to run. And these commands are roughly similar between different infrastructures code tools. So you need to do some form of initialization. You need to do the preview or plan, as it is called in Terraform. And once you have the plan, you need to apply the plan. So it's guaranteed that you're applying the thing that you think you're applying. So, in different systems, it might be called differently, but the basic concept is there. So for example, in CloudFormation, you generate a change set and apply a change set, and so on and so forth. So when you have those phases, you can actually wrap those phases in custom scripts. So for example, if you want to use something like Helm in order to generate Kubernetes templates, well, you can basically run Helm to do things before planning, right? So you want to use it as a preprocessor. Or if you're using a CDK for Terraform, you can run Terraform CDK generator in order to generate the Terraform code. You can also talk to external systems from those, we call them hooks. So if you want to, for example, grab some secrets from your vault, you can basically grab them and put them in the environment, and they'll be available throughout the run. And so that's the idea. That's the kind of like the idea of being flexible enough to cover both worlds, the specialized and the customizable. So each stack is generally connected to a repository. When that repository receives pull requests or changes, we effectively run Terraform plan on it, if that's a Terraform resource, right? So we have, Terraform checks. It seems that most plans contain no changes, but one plan contains changes, and you can see what changes there are. Some random string is changing. If you want, you can go to the run and see what's exactly going to change. Some random string is changing from one value to another. And once you merge that pull request, that's the default behavior, that will be implemented on your stack. Of course, you can connect as many stacks as you want to a single repository. People with up to 11,000 stacks running from the same mono repo. So the possibilities are pretty much endless. When you look at one of those runs, you can see that they've been, going through multiple phases, preparing initialization, which is pretty much Terraform init, planning, Terraform plan, and then if you set auto apply to on, and there are no warnings coming from different policies, etc., then you can just auto apply. And in this case, you just auto apply the changes. You can see the changes here. The summary. You can also look at the resources that we're managing, for example, by type. This is just a demo, so nothing very fancy, just 4 random strings. So this is generally the idea of stacks. So obviously stacks support different technologies. I've been showing you Terraform, but we also support Ansible, CloudFormation, Kubernetes, Pulumi, Terragrunt, etc. For an Ansible stack, Ansible is actually a bit of a departure from Infrared because it's like it's imperative, it's not declarative, but it works as well. Like you can basically say, okay, please run those playbooks for me on my targets, my list of targets, and that's essentially what happens. During the plan, we run preview. We show you what's going to happen. You can have a policy, for example, that requires all hosts to be reachable. And if they're not, maybe you want, I think there might be like a good example here. You can see that one of the hosts was unreachable. And there's a policy, and I'll be talking about policies a little bit later. There's a policy that requires manual confirmation if there are unreachable hosts. The author actually didn't want to apply. They discarded the plan. And so they never run the playbook. So this would be Ansible. We also do have things like Pulumi and Kubernetes. We have a Pulumi, very similar. The planning, you get the exact change. Actually says, I'm going to create 3 things, right? And the change was discarded. Okay, so very, very similar. Like you pretty much get like Atlantis for Pulumi, or Terraform Cloud for Pulumi, Terraform Cloud for Ansible, etc. within Space. The second thing I suppose worth talking about is the module registry, the private module registry, which is also, again, a slight departure from what you see in Terraform Cloud. Similar, but it's slightly different. Because in our case, it's not only like a glorified package manager, but it's also a testing framework. So you can create test cases in your repository. You can create test cases, and each of the test cases is required to pass before a version gets green and is usable by the rest of your organization. So you can create positive test cases that ensure that things actually apply, but you can also create negative test cases that ensure that, you know, if you run your module with like bullshit inputs, it will not apply. And this is actually creating and destroying real resources. So you'll get a plan that shows you what's happening. You can run policies on those plans. So, you know, you kind of shift your security left. We'll apply those changes and we'll destroy those changes. And this is to ensure that the module applies cleanly and destroys cleanly, because sometimes you have this problem where, okay, it plans well, all good, but then you try to apply it and boom, something doesn't work. Or it applies, but you can't destroy it because some setting is there that doesn't allow destruction. And so we want to ensure that indeed you can do things. All right, so module registry is also like a CI/CD sort of system. Last but not least, what I'd like to show is the policies. And the policies, that's not how I wanted to do this. Policies are very different in Spacelift than in some other places you've seen. So if you've been using policy as code, for example, through the Hashicorp suite, they have their own policy language called Sentinel, a proprietary, well thought out language generally for establishing rules. Spacelift, however, is slightly different. We don't use Sentinel, obviously, because it's a proprietary language. We use something called Open Policy Agent, or REGO, and that's Cloud Native Computing Foundation project sponsored by a company called Styra, and it's very famous, especially in the Kubernetes world. Like, Kubernetes community seems to like it a lot, and it's spreading like wildfire to different places. But that's not the point. Like, the point I'm trying to make here is that we use policies differently than most people, because we use them as decision, like we use them to split decision making from decision enforcement. And traditionally, the decision making with policies has been, this looks good, this doesn't look good. So it's like a policeman, right? You go, you stop, you go, you stop. And that's fair. Like, it's a very fair use of policies, but to me, it feels like it's very restrictive. So to me, it feels like there's so much power in the policy language that goes unused in this scenario that it's a waste. In Spacelift, we also use policies to define workflows. And that is on multiple levels. So we have a number of policy types in Spacelift. Now, I'm not going to be talking about all policy types, but in general, like, we have, starting with the login, where, you know, you give us some information about yourself, or really your identity provider gives us that information, and we decide whether you should log in or not, or with what permissions you should log in. You give us the logic how to do it. We get the data and the magic happens, right? We apply your rule to your data, and enforce the decision. Okay, so far so good, that's simple. What about things that are not so obvious? We have something called push policy, which is evaluated whenever we see a get event. And it could be a push event, it could be a pull request event, it could be a label event on a PR, and it could be a comment event on a PR. So we get that data, and then what should we do about it? So basically, when you attach a policy to a stack, for every get event on that stack, on the repo that is connected to this stack, we'll execute the policy and we'll do one of the three things. And the three things is, this is a deployment candidate, this is a test candidate, I don't care, I want to ignore it. And that's very useful for people who are, for example, using monorepos, because in a monorepo scenario, when you have, I don't know, 11,000 stacks connected to the same repo, you generally wouldn't want to have 11,000 jobs running for every little change that you make. And so that's where push policy comes in and says, okay, this change is relevant for this stack, but not for 10,000 others. And that's very, very useful. And also goes against how most people would use policies. Other workflow policies are, for example, approval policies. And here we look at, okay, this is what the change is all about. It comes from a pull request or it comes from a push. That's the author, and that's maybe, you know, that's the repo, etc. So this is the data about this change. And then the questions you should you can look at each run in two phases. So first, should I plan? And then should I apply? And those might be two separate instances of an approval policy running. And that approval policy can be like very, very sophisticated, starting with like, anytime I make a database change or I change one of these files, I want a security person to approve it. Anytime I change, I don't know, a database, I want to have a DBA approve it, etc. Or I might need 3 different approvals from 3 different people within 5 minutes from one another to approve a really nasty change. And so you can define those rules using approval policies. Again, it's not a binary thing, although it ultimately translates into it's good, it's bad, but it's a state machine. Last but not least, and that's one of the policies I love the most, which is a trigger policy. And trigger policy is generally designed to look into relationships we have between different stacks. It's like one way of doing Terraform, an extremely naive way of doing Terraform, is everything is in one state. And I've been there, I've done that. And like I have 7,000 resources and it takes 50 minutes to refresh all of them. And so I was like, oh shit, how do I break it, right? But when you break it, you would have relationships between different stacks, and they could be expressed as, you know, remote state files that you read as data sources. They could be expressed as something sets a resource, the other thing reads that, maybe in parameter store, maybe in secrets manager, etc. But in general, they could be like a data exchange between stacks. And how do I make sure that if one of my stacks changes the data, the other stack depends on how does the second stack know that it should run? And that's trigger policy. Trigger policy gives you the exact state change and asks, essentially, it's like a event bridge for all your state changes between Terraform, CloudFormation, Pulumi, Ansible, etc. It basically raises like, hey, that's a state change. Who cares about it? Who wants to update? And different stacks would then say, I care, I don't care, I care. And the trigger policy goes like, okay, these stacks care, let them run. And this allows you to create really fancy deployment mechanisms. So starting with, you know, like trickling down your change to all of the leaves, to things like stage deploy. So for example, you deploy to the canary. Once the canary is green, you run trigger policy to run pre-prod, and then maybe 50% of your regions, and then the rest of your regions ultimately. So that is one way of basically doing a stage rollout using declarative policies. Which I believe, takes me to the end of my scheduled programming, and time for questions.
Yeah, feel free to hand up in Zoom or write your question in Zoom chat or YouTube chat, and then I will repeat them. So, did have someone question? Because if not, I have one question. Marcin, what about we have some problems from Terraform applying? For example, all time when we stop some environment, you need to provide mostly administrator access to all applying agents. Do we have something in Spacelift to make restriction who can apply or something like that? Because it's really a big problem.
Yes. So we have many different ways of restricting that, from role-based access control, basically saying one person has access to this stack, but not to another stack. So like if you don't have access to a stack, obviously you can't apply. So that's the first thing. The second bit is the approval policies. And approval policies basically give you custom rules that you can establish to say, okay, it's not only who can approve, but also what can they approve, under what circumstances. So for example, you can say that if someone is changing a database, that requires an approval from a particular person. If they are changing a different type of resource, that requires an approval from a different group. So you can basically make that very, very granular, and not only single approvals, but those approvals could be connected. So not only you might need an approval from a security person, but also from a DevOps director, or maybe from 3 different people in that particular group of users. And so this is very, very powerful, like, approval chains. Last but not least, you have something called plan policy, which is very similar to what Hashicorp Terraform Cloud does with Sentinel, which looks at the resource that you're going to create, and it gives you 2 levels of rejections. Either you have a soft rejection, in which case you're back to manual approval, or it can give you a hard rejection for certain rules that are non-breakable. So for example, if someone tries to open a S3 bucket to the public, you might want to say, there's no circumstance in which I'm allowing you to do it, or allow all on a particular group. You might just know it's new things in this company, and boom, that's it. So many layers on which you can implement those controls.
This sounds very powerful. Also, Igor asked how this tool fits into GitOps model.
It's like, essentially it is a very GitOps thing, because you can't apply something that is not checked in. Like, we generally, yes, we allow you to preview things that are local using our CLI, but if you want to apply, if you want to push those changes, there's no way you can apply something that is not checked in. And so the default flows that you check in, you open a pull request, you give your feedback on the pull request, you merge the pull request, and it's an apply candidate. Of course, you can customize it. Some people say, okay, I really like the Atlantis way of doing things, and I want to apply from pull request and get the feedback on a PR. And you can do it, but also subject to role-based access control. So you can say, okay, well, that PR is still not approved, so we're not allowed you to run this particular flow. So we generally, like, the 99.5% of Spacelift interactions are actually through some form of Git flow, with the reminder being people manually previewing changes because they don't want to go through the whole, git add, git commit, git push, get feedback, change a little one line there, and do it again and again. But mostly it's git flow.
Thank you. And Sergey asked, can SpaceLift replace GitLab or Jenkins, etc. completely, or it's dedicated only to infrastructure management and does not work for app deployments? If so, what are the top benefits SpaceLift provides that cannot or hard to be implemented with some custom scripts stored in GitLab CI?
Yeah. So can SpaceLift be a general purpose CI? It can. Will it be a good general purpose CI? No. Should you use it this way? No. Should you keep using GitLab for that? Yes. What SpaceLift brings is the level of specialization. So SpaceLift generally understands exactly how to show the resources that are being created, how to persist state, how to serialize the deployments, how to route different workflows through different policies. So it gives you that very well thought out multiplayer mode. If your question is, can I build it myself on top of GitHub Actions or GitLab? Is that, or will you do it? Well, depends on your use case. Maybe it is. Maybe if you need just very little automation and your use case is pretty simple, then I'd say yes, you probably don't need like a fancy specialized tool for that. But if stakes are high, if your organization is complex, if you need a lot of automation and you need to automate your automation, because like a lot of people will just set up Spacelift using Terraform, we have a wonderful Terraform provider, then it might be cheaper to buy a specialized tool than to build everything yourself, because there's so many things you need to consider when you're building things yourself. Will they keep working in 1 year's time? Will the new guy understand them? Will they age well? How much time do I need to spend on ongoing maintenance, etc., etc., etc.? So it's never just building one script and leaving it there. Like every software will evolve for as long as it's being used. And so you have to answer that question for yourself. Is it worth it or not? But of course we built it, so you can build the same thing. It's just a matter of, is it worth? I don't know. Sometimes yes, sometimes no.
Let's try and win the wheel. Okay. Andrei asked, your trigger policy allows you to set up some dependency between Terraform repos, but is there any way to generate a diff between these stacks? Example, I have one stack that will trigger actions in second stack according to trigger policy. How would I see changes that will be in second stack without applying changes in first repo?
Yeah. So when you make one change, the first stack will generate like a run, and then that run will get something called a policy receipt. So it'll say in the policy history, it'll say, I triggered that other stack, and this is the job. So you can, and it generates a link to that job. So you look at that job, and you can jump through like the whole workflow. And if that is not auto-applied, then you can see that, okay, this is the diff, and you can decide whether you like it or not. And it's subject to the same approval policies, subject to the same confirmation flow as all other jobs.
Thank you. For now, it's all questions. So if we have no questions, thank you, Marcin. Also, just notice that we also have, let me stop partition sharing. We also have after party where if Marcin have time, you can ask him other questions. Otherwise, maybe I can answer your questions because I already customer of SpaceLift, so have some experience with this CI. So feel free to ask. Thank you, Marcin.
Thank you. Bye.
Yeah, bye. Also, next speaker is Pato. Let me try to.
Hello.
Hello.
How's it going? Let me just adjust my camera a little bit. Let's see.
Yeah.
It's better.
Yeah.
Hey, I like standing up, although most of the presentation is going to be slides. All right. So we're ready. Should we start? Let me get the presentation going. Hang on. Let's see. Do you see
Your screen? Yeah.
you see the slideshow still?
Yeah. Yeah.
Okay, great. Awesome. Well, hello. I think it's evening in Kyiv. It's middle of the afternoon, or rather noon here in New York City, where I'm located. Thank you very much for having me here. Max was very gracious in inviting me. I know this is a difficult time for everybody, so I'm glad we can be here for a little bit to talk about something else. And hope I could do more, but this is what I know. This is what I do. So this is my contribution. All right. So I recently wrote a Terraform provider, custom Terraform provider, something that was kind of something I was curious about. Decided to do something on a little bit of my free time. Ended up being kind of useful. So I put it out there. So it seems like other people are using it. And I guess I'll talk a little bit about why I built it and how. It's not exactly going to be a walkthrough or a tutorial. It's not a hands-on lab. It's more of a just kind of walk you through how to get the inspiration or how to get started and where to look, and just walk you through a little bit of what I like how I approach it. So again, we're going to talk about, I'm assuming most everybody here is familiar with Terraform. I'm going to give a brief overview, assuming there's at least one person that's not very familiar. Then we're also going to talk about the Terraform providers, so that part of the Terraform ecosystem, or the Terraform stack that deals with the APIs. We're going to talk about OpenVPN Cloud, which is the provider for which I the API for which I wrote the provider, and also how to actually write the provider, distribute it, and a few other things. Right. Before we move on, I want to talk just briefly about me. My name is Pato Arvizu. I'm a lead platform engineer at a company called ASAP. We're in New York City. In fact, right now we're in our offices. I'll tilt the camera around in a minute to see if you can see the skyline here. We're in the 80th floor of the World Trade Center, which is pretty good. If you ever here in New York City, be more than happy to give you a tour. Just in two statements. What we do is a customer interaction platform. So anything that imagine when you have to talk to your bank or your airline, whatever, we build stuff for that. And we throw in a little bit of natural language processing formula there. So imagine that you're not talking to a bot, but you're talking to a human that is has been improved with stuff that we can detect from natural language processing. Cool. So I was unofficially a Hashicorp ambassador at my company until the company Hashicorp created the ambassador program, and I was selected for the first, I think 2020. Jasmine, I know Jasmine's online. I don't know if you have the data when the first generation was, but I think it was 2020. So this was the third year, and I got selected again. So I'm really happy to be ambassador both within the company and the community. And I guess me talking here about this is proof of that. Cool. So again, a brief overview of Terraform, in case you're not familiar with it. So Terraform, it's kind of always usually defined as infrastructure as code, but I want to change it a little bit to say it's declarative APIs, because with Terraform, sometimes we manage things that are not exactly infrastructure. They are things like even just random numbers, random passwords, TLS certificates, local files, so things that are not exactly ELBs or databases or VMs. So it's more about the declarative API, or the way of declaring the structure of those APIs. Also, the important thing, and we just saw it with Spacelift, is the state management. So it's not about just like running a script and creating the things. It's about knowing what the state of the things are to then do the reconciliation. So also the other thing is it does control planes orchestration. So you don't run just a just declarative APIs for one control plane. I mean, like for example, just for Amazon, just for GCP, just for Azure. Terraform can do the orchestration between multiple of them, and it does so through like input and output. Well, there's a few other things, but input and output linking. So if I have to create, say, a KMS key in AWS, but then save the value in I don't know, like a bucket in GCP, then Terraform can orchestrate those two things without it having to you having to write specific logic for it. So now Terraform providers, that's the part that we're going to talk about today. So this is kind of a simplification of the stack of Terraform. You have the Terraform 4, which is the general code that does validation, state management, schema detection, things like that. Then there's a specific individual Terraform providers, which communicate with Terraform 4 via RPC. They are separate binaries that do the wrapping for like a structure of schema of the resources, data providers, etc. And then that usually is tends to be decoupled from a client library that wraps the actual calls, the actual REST API to the target API. Sometimes they're bundled together, but they tend to be separate. So there's kind of three classifications, I guess, of Terraform providers. The official ones are the ones that are maintained by Hashicorp and owned by Hashicorp. So examples are AWS, GCP, Azure. Those are the most popular ones, I guess. But also like Kubernetes, for example, is very popular. And even though none of these technologies are associated with Hashicorp directly, they own and maintain the providers. Then there's also the verified providers. These are more providers that are owned and maintained by other technology providers, technology partners. So things that are popular in the industry, like, oh, my clicker went, hang on, because my clicker stopped working. 1 second. Is it? Okay, there we go. Yeah. So verified providers like Cloudflare, Datadog, Auth0, Grafana. These are all, again, not associated with Hashicorp, but these are owned and provided usually by the company itself, that the cloud provider, the technology provider, but separate from Hashicorp. And then there's the community ones, such as the one that we're going to talk about here. OpenVPN Cloud community ones are maintained by individuals, or maybe smaller organizations that are not directly associated with the technology in question, but have an interest there. Okay, so now OpenVPN Cloud itself as a product, it's a little different than OpenVPN that we've probably everybody knows about. So OpenVPN is a true and tested provider or model for OpenVPN connections. There's a few other different ones, but this is one that's very popular. OpenVPN Cloud is an offering from the same company, but it's a different approach or alternative to the classic model, where the classic model being where you have some host or some virtual machine that's exposed to the internet that then your clients connect to, and then there's authentication, credential exchanges, and then that server's network is the one that provides the connection to either the intranet or externally. OpenVPN Cloud is a bit hybrid, where you have the control plane in the cloud. So the OpenVPN Cloud servers, I guess, they're the ones that provide the interface both to like the API to create these resources, but also to act as an OpenVPN server that clients can connect to, that existing OpenVPN clients can connect to, but you provide the data plane on your premises. So OpenVPN Cloud doesn't give you egress to the internet. You have to have a what they call a connector in the middle, where the server in the cloud connects to that connector, and that's the one that gives egress connectivity. So it's the benefit of this is that you still have the availability of the server in the cloud, but you maintain control of the data plane privately, right? So this kind of gives is a nice it provides value in that you still know where your data is going, while the availability is outside of you. It's free. It has a free tier, fully functional up until 3 active connections. One connector, with the thing that sits between the control plane and data plane, is one connection, but then you have 2 other available connections for clients or users. So this is good for small groups, family, home, etc. But the most important part that is relevant to this is that it provides a programmatic API in the form of a REST API that you can write a library or code around to create and orchestrate things. So this is an example of it. A lot of you will be familiar with what a Swagger UI kind of looks like. It's showing the endpoint for connector, which is, like I said, one of the concepts there, and it shows the methods and the endpoints that you can use for different actions on it, right? So why did I write the provider? Honestly, I guess when I was trying to write this slide, I don't know. I guess I had a few reasons, but nothing was pressing me for it. One thing that I can say is that I have an elaborate home lab setup at home, for which I have 100% in code, or maybe 99% in code. So every time I add something new, I try to see if it's possible to write code around it. Not code, but declarative code. So have things either in Kubernetes, Terraform. Haven't played with Pulumi yet or any of the other providers, but I try to have everything in code. Again, Terraform is the infrastructure as code language of choice. There are some things that are more native to Kubernetes, so those belong there. But still, in that case, I try to use the Terraform provider for Kubernetes. So still trying to do everything through Terraform. And honestly, to learn, like to be honest, I'm kind of jealous of people that can just sit and create some project and suddenly they do it in 3 days, and the next day they have 10,000 stars in GitHub. I wasn't doing this to get the 10,000 stars. I was doing this to learn and try to move things forward and get to the next level. Also, a bit of a challenge for me is that I'm not as proficient in Go as I'm with something else. I have been writing Go more recently after several years of not doing any backend development, but now with more Kubernetes. Generally, the CNCF ecosystem is very Go friendly, so that helps things, and rather that kind of forces you to stay up to date with Go. But it's also a way for me to keep practicing there. Yeah, the clicker's broken again. 1 second. Wait. Okay, so I was going to show you my home lab just real quick. This is I have a Raspberry Pi Zero connected to the sound system, so it acts as an AirPlay server, so I can put music throughout my apartment. That's another Raspberry Pi Zero with a temperature sensor that I take the temperature of different rooms in the house. I have a few of these, and push the metrics to our Grafana, sort of Prometheus database that I have that I then visualize with Grafana. That's kind of the same thing, but it's an external temperature sensor, and that's kind of the brain of everything. I have a 5-node Kubernetes server cluster. I have a Tor node there, and I have 2 OpenVPN. Have 2 hosts where I'm running OpenVPN connectors there. Inside the Kubernetes cluster, I have all sorts of things. I have Vault running, Grafana, Prometheus, a bunch of things that I really don't have. They're not really critical in my setup, but I like to have there and kind of play around and try to keep up to date and see the challenges that there are, so that when it's time to upgrade what we have at work, I already have that experience. Okay, so give you a lot of background. Let's take a little bit of time to see some actual code. So I'm just gonna switch to setup here. I'm gonna turn off the camera for a second, and I need to switch to share. And let me. Okay, there you can see Visual Studio now, right? Let me increase the font.
Yeah.
Okay. Okay, so again, this is not going to be a walkthrough. It's going to be more of just like generally talking about it. But there's 3 things that, in fact, kind of make it easier to do the or to get started and make it not be as intimidating when you have to code. Actually, I would say 4 things maybe when you have to code the provider. So if you're familiar with Terraform, you usually do 3 things. One is you configure the provider block. That's when you enter like the different credentials that are different attributes that you need for your specific provider. So credentials, URLs, user IDs, etc. Then you need to write the code for the data sources, and then the code for the resources, with like the actual things that are created. And then the other part is the client code, which if there's no existing client for the API, then you can write it yourself, or you can write your own wrapper. But if it's something that's already existing, you can use the existing provider, the existing client library. So an example of the provider logic, and by the way, this doesn't have. I mentioned earlier, there's the Terraform core, then the Terraform provider wrapper, and then the client. The Terraform provider wrapper doesn't have any logic. It just does things like schema validation and things like that, or schema definition as well. So that's this part. So in the case of the OpenVPN cloud provider, we only need to know the base URL, which is each account has its own base URL, and then the client ID, client secret, which are the credentials that you need to generate. So you need to bootstrap these credentials once you create the account to be able to use this, but there's that. The other thing that the Terraform provider SDK provides is a lot of very utility functions and very useful things to automatically set the default function to detect from an environment variable instead of you having to write something. So it detects this environment, it looks for this environment variable, and if it's set, it sets this thing here instead of whatever, or use that as a default, right? So it doesn't need to be defined. That's why it's set as optional. Same with the secret. So this here, it's like the list of resources and list of data sources. So for each one of those, there's a function that does the for each one of those, there's a function that's associated with it that provides all the CRUD operations. So create, read, update, delete in the case of the resources, or just the read in case of the data sources. Some kind of scaffolding to create the client that is going to be used throughout the operations. So let's use the connector as an example. Again, connector is a specific OpenVPN cloud concept. Is not a Terraform concept, but it's an object that does the linking between the cloud and your data plane. So for the data sources, they're a little bit easier in that you only need to implement the read function. We need to define the schema. So the schema is it kind of provides two functions. One is what the user of this provider will need to define to use this resource, but also what the client or the upstream API is going to return to the client. So like what values are going to be available to use or to read. This example, the only required field is name. So what this does is that it looks up an existing connector based by name, but when it returns, it has all these other attributes to it. So network item ID, item type, VPN region ID. So these are all OpenVPN cloud specific fields. Then this is the actual read function. So this is the one that talks to the client, for example, here. So it gets the connector by name, gets the connector, and then we use the SDK libraries to actually set the values there. So what this does behind the scenes, again, which is done by the Terraform core part, is that it handles the state management, and it creates an object with these values that then it can be looked up by other resources, or we can use it to create outputs. Other data sources are similar in that you define the schema. Some schemas can be nested when you have a list of things, and then you implement the read, and that's basically it. The resources are a bit more complicated because for a resource, let's go again with the connector example. For resources, you have to implement not just the create, but also the read and the delete, right? Because like the first operation is usually the create when you're starting when the object doesn't exist and you're creating it from scratch. And then read is used to for like drift detection or for detecting changes in between runs. And the delete is to do cleanup once the object is removed from the declaration. The provider also needs to know how to do the cleanup in the actual existing API. And then also, if you're familiar with Terraform import, you can kind of bring into or adopt existing resources into your Terraform cloud, your Terraform stack, so that you can continue to manage them through your Terraform code. Similar to the data sources, you have the schema here. In some cases, or in the case of resources, you can do additional things like define a validation function. In this case, we want to make sure that network item type is it's a specific string, either in our case, network item type host or network item type network. These are two specific values that the only available values or accepted values for that field. Again, quite simple schema with only a few fields. The create function, it's maybe a little bit complicated because you have to create the scaffolding for the client. Then you call the client does the API, client comes back with a response, and then that's when we set the any additional values in the state. Read is similar. You create the object. Oh, sorry, you take the parameters, you make the call, you get an object, and then that object is what's set. The delete, can take a similar form. In some cases, the delete might be a bit more complex because you need to orchestrate other things, do maybe wait Sometimes the delete is asynchronous, so you have to implement a wait on the client side, etc. Then sometimes there's kind of private utility functions here. That is kind of basically, I guess, in our case, the client is bundled within the same. It's not in the same. This is in the same binary, or sorry, Hashicorp recommends that it's not in the same binary or even the same repo. In our case, it is. If this were something that would grow very large, it would make sense to separate the clients, but in this case, it's not necessary. So, this is basically the kind of the data access layer for the provider, where we define a JSON schema here, and then each of these functions corresponds to an action on the upstream API, right? So I think that's it. Like it's one thing I kind of regret. I guess I should have had some examples for you. Don't have a lot, but they I guess the one thing is that you can this is something that you can take home as an assignment to try to play with things yourself. Let me go back to the presentation. Let me stop sharing this. Give me 1 second. Real quick. Okay, so do you see the presentation again?
Yeah.
Good. Okay, so again, kind of back to how to write the provider. There's not really a walkthrough example, but Hashicorp Learn has guides. I don't know if you're familiar with Hashicorp Learn. You can find it at I think it's learn.hashicorp.com, and it has guides for everything around Hashicorp, all the other tools in the ecosystem, but specifically for Terraform providers, it has guides on how to do it. And I'll post links at the end. Again, writing it Go, it's easiest because that's kind of like the native way. I guess technically, because it's RPC, you can implement it in other languages, but I don't think it's recommended, and it's probably not really supported. But I guess if it's something that you want to try, you can give it a try. If you want to write a provider for something, a new provider, try to find something that has a free API that you can implement a provider around. There's many different API directories or aggregators. I have 3 here. One that I use is Rapid API. Sometimes I just browse it to see if there's anything cool, anything new to write code around. So that's a good resource. There's also Programmable Web. I think has a directory. Again, I'll post links at the end. And APIs.guru is something I discovered recently. So look for something that has free API that, or maybe something that's affordable to you, a few cents, any of your local currency. Then start small. There's if you want to sort of like get familiar with it, start small. You can write a provider that's just data sources for things, right? So a lot of these APIs, so I'm assuming every single API has something that is read-only, so you can write a data source for it. You can also start with something that's an actual resource, but a small number of attributes, and preferably a flat set of attributes, so that you don't have to do any kind of nesting of attributes and nested validations and things like that. Or also work with immutable resources, because anything that's immutable, it's easy. You don't have to implement the delete or the read function. There's a reduced surface area because any changes to the attribute, to the resource, means that you have to recreate the resource. So there's not a lot of logic there. and document it and publish it. So the documentation is really easy to do because there's tools around it. The tooling around it is still kind of getting updated, and there's just some bugs to walk through. But there's things available, and it helps for the adoption of it. And then also publishing it is really easy. There's, again, in Hashicorp Learn, there's links for it. And oh, you know what? I'm just realizing that I forgot to turn the camera on again. 1 second. So I know this matters for the YouTube stream. There we go. Oh, let me skip the skin. Yeah. So yeah, document it and publish it. That's really good for adoption. If you want other people to start using it or contributing it, even for yourself, just kind of make sure I find that documentation, not just in Terraform, but find the documentation is a good way to help yourself stay consistent with your own thing. So, go ahead and do that. So a few lessons learned from this. I'm still a Go newbie. There's a lot of things I don't know about Go. There's how to organize the code, how to use the dependency management properly, how to put files in different directories, what are the best practices. There's a lot of things in Go that I still don't know about, but this is good practice. Naming matters. There's quirks in the Terraform kind of convention that you want to name something, for example, OpenVPN_cloud. That's not going to work. You have to name it OpenVPN cloud, one word. There's things in the Terraform ecosystem. There's things in the Go world that matter when it comes to naming. This is actually easier than I thought. I thought it was going to be these like larger, more complicated things that are going to have to go through a lot of guides and talk to people and see videos or tutorials. It was actually easier than I thought. Granted, you need to have some understanding of how Go works and Terraform and a few other things, but if you have that knowledge already, then it's not that complicated. Especially if, like I said, you start small, start with like the easy types of resources. And if you have a use for it, probably somebody else does too. When I started writing this, again, I did it just for me. I did it because I wanted to keep my my setup in code in Terraform. But a couple weeks later, I found that somebody made a PR on it because I guess they were using it, and all of a sudden I had like 10 GitHub stars, which is not a lot, but it means that there's interest on it. So go for it. If nothing is more satisfying, I guess, than finding out that somebody finds value in your work, right? Even if especially if it's something that you did it for fun, and then it turns out that it's useful for other people. What's next, both for me or for anybody interested in this? Try it yourself. Go and I'll post a link again at the end, or you can find it in my profile. Try it for yourself. Again, OpenVPN Cloud is free. You can get an account and start playing with this. If you have an old laptop or old server, or even your own laptop, you can try this thing on any of those. Help is wanted. If you find bugs, create issues, comments, typos. Tests was the other thing I forgot to mention. I'm bad at test. I'm good at knowing when things need to be tested. I'm bad at actually implementing and executing tests, but that's something that if you're available, you could also help with. I know that there's frameworks for Terraform testing that I haven't gone through, but that's something else that's available. Issues, documentation comments, etc. Anything that's helpful. Even if it's a typo where I missed a word or I misplaced a letter, then that's really helpful. That's great. If you like it, if it's something that you're interested, a star would help me here and there, to get a little bit more visibility, a little bit, raise my profile a bit. Here are some links. I'm going to post them in the YouTube chat after this, but you can pause here and follow them if you're watching this later on. the documentation for the providers itself. Then there's the Hashicorp Learn guide for you to walk through. OpenVPN Cloud, there's kind of documentation on how to sign up and get started, and then the 3 API directories I mentioned earlier. That's it for me. Thank you very much. This is where you can find me. Not really active on Twitter, but you can find me there. If you want to chat, you want to reach out to me. My username in almost all platforms is Pato Arvizu, so that's where I can be found. I'm around for questions, by the way, if you wanna do that. So let me I'm gonna stop sharing this. And yeah.
Just a reminder how you can work with questions. You can raise hand in Zoom or write your question in chat, Zoom or YouTube, and I repeat them. Also, thank you, Pato, for your talk. And I have questions that I got about an hour ago. Did you try Terraform plugin framework that was released about a year ago by Hashicorp?
No, because that's a good point. I didn't want to go too deep into it. So there's a Terraform plugin SDK, and then there's a Terraform plugin framework. And I think Terraform plugin SDK, there's version 1, version 2. The 1 is deprecated, I believe. And I kind of thought about it, and there's documentation and guidelines from Hashicorp on how to do this or how to make the decision. Because this is something that, again, I thought it was going to be just for me, and it's not really very enterprise, so it didn't need to be production grade. I went with the old one, which is the SDK version, also because there are more examples for it in the existing providers. Like at some point, this means that a migration needs to happen, which is like I made a conscious decision of deferring that work for later. But no, I did use the SDK, not the plugin framework.
Great, thank you. So, questions?
There's nothing in the Zoom chat. I don't know if there's anything on YouTube.
YouTube, nothing to. Also, you got achievement. You first speaker who had issues with clicker on online event in Kyiv.
Really? Like actually, this is my first time. I tested it my first time using it. I bought it like a week ago, and actually it has a laser pointer thing. I don't know if we can see it here. It's probably not very visible, but yeah, and it's a Bluetooth thing, but it worked and it stopped working after 10 minutes. So I don't know if it's a Bluetooth thing or what.
Maybe, yeah.
Yeah.
Okay, no questions. So thank you, Pato. I remember that we will have after party in a few minutes in this Zoom. So if someone have a talk with me or who will be else, please join. I will send Zoom link to YouTube chat. So if someone like to join, please join. And
thank you very much.
Please,
oh, you know what? One thing I forgot. I was going to show you the view of New York City that we have from our office. I don't know if.
Nice view.
Part of it, yeah. I mean, it's kind of bright, but yeah. Great. Thank you for having me. This is a good experience, and again, hope things get better for everybody soon, and hopefully there's more we can do.
Yeah.
Thanks for the invitation again.
Yeah, sure. And please don't forget to support Ukraine. When you support Ukraine, you support Kyiv too, to exist, and all Ukrainians in the world. I'll stop translation.
I see there's just one more thing in the Zoom chat. Okay, no, just saying.